Hi everybody. I wanted to do a little exercise on binary decimal and binary to decimal conversions for you, following on from the number systems lesson plan from last week. Now I know you may not have gotten this far. If you haven't, don't worry, but I just wanted to do a couple of these for you in case you had. I was hoping to try and record the whiteboard on Microsoft Teams, but it doesn't let you do that just yet. So here's my attempt, okay? So I'll be flicking between me and the whiteboard a bit. Hopefully you'll be able to see it. All right. So we talked about number systems last week, and we mentioned binary. Binary is either a 1 or a 0, if you remember. So if I want to convert from a decimal number to a binary number, I need to know what my exponents of 2 are. Okay, so this is why I've been asking you to look at exponents for the last while as well. So you can see that 2 to the power of 0 is 1. You remember that from a previous lesson. 2 to the power of 1 is 2. 2 to the power of 2, sorry, I'm going the wrong way. 2 to the power of 2, that's 2 by 2, which is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. You're just doubling the number every time when you're dealing with powers of 2. 2 to the power of 6 is 64, and 2 to the power of 7 is 128. Okay, so if you have a number like 14, that's our ordinary number 14. In the there, number 14. Okay, base 10 means it's our ordinary decimal system. Okay, what we need to do to convert from a decimal number to a binary number is figure out which of the powers of 2 that we can use. Okay, so if we go as far as 16, 2 to the power of 4, okay, that's already too big for us, isn't it? Because all we actually need to know is what 14 is. So we don't need to go as high as 2 to the power of 4. Okay, let me just stop there for a second, and I'm going to draw a couple of lines in because hopefully it will make more sense for you that way. So just pause for a second. Okay, back again. So you'll see I've drawn a couple of lines here. I'll explain what they're for in a second, okay? You'll also notice that my writing is just as crooked on this whiteboard as it is in the whiteboards in the room. But what we were saying was that with 14, okay, we need to figure out what adds up to 14 in terms of the numbers that are powers of 2, which is why we said 16 is already too big. Okay, so we don't need 16. We don't actually need the 2 to the power of 4 because it gives us too big a number. Okay, but there is an 8 in 14, isn't there? We can get an 8 out of 14. So there's our 8. That will leave us with 6 left over. Now, what can we make 6 up out of in terms of the powers of 2? Well, we can use a 4 and a 2. Okay, so what you have here is an 8 plus a 4 plus a 2. That would give you 14. Okay, that's fairly simple. Let's take the lid off this. Okay, so 8 in our binary system is 2 to the power of 3, isn't it? Okay. 4 in our binary system is 2 to the power of 2. Okay, so that's 2 to the power of 2. And I can draw arrows slightly off. There we go. 2 in our binary system is 2 to the power of 1. Okay, and we've nothing here at 2 to the power of 0. We don't need a 1, okay, because we've got a 2, a 4 and an 8 here. Okay, so if I draw a couple of lines underneath there again, hopefully they're underneath, something like that. Okay, so we have nothing here. Okay, we do have something here. That's a 1. We need this 2. We need this 4, so we have a 1 in the 2 to the power of 2 place as well. And we need an 8, so we put a 1 in the 2 to the power of 3 place. And the number that we get in binary is 1110. Okay, so 1110 to the base 2 is equal to 14. Now that's getting lower and lower on you. 14 to the base 10. Okay, so that's how you do a simple decimal number. Okay, I'm just going to watch this back and make sure it's okay for it to send on to you. So if it is, I'll send this on and we'll do some more examples. Okay.